Hello, Introduction to Java Programming. In this session, we will discuss about looping statement, especially while and do while. Let's begin. So as part of the basic programming constructs of Java, we are discussing control statements. And as part of control statements, we have looping statements, or we can call them as iterative statements. They are while, do while, for, and there is a variant of for that is actually for each. Let's understand while and do while in this particular session. We know why we require looping or iterative statements in any programming language. Whenever you want to execute a piece of code for multiple number of times, then you can actually go for a looping statement. Starting from the C language, we have these looping statements, and almost all programming languages, whether they are high level or scripting languages or low level, whatever they are, so these looping statements are available. Especially we have while and for available, and some programming languages don't have do while. As an example, in Python we don't have any do while. Let's understand these looping statements. So whatever the looping statement we speak of, there are three properties associated. Whether you write a while loop or do while or a for loop, there are three properties associated. One is the initialization. So you should initialize some variable, and that variable is going to be the looping variable. Okay, as an example, some int I that equal to 1. So this is actually the initialization variable for the loop. And this variable we are going to use in the loop actually, which controls the loop, like how many times the loop has to get executed. Okay. And then there is another property that is actually a test expression or test condition. Okay, how long your loop has to get executed? Is it infinite times? Is it only one time? Is it no time? That means 0 times, or some n number of times. So that is determined based on the condition or the expression. Okay, so this we will specify in any of the looping statements. And of course, we will have an update statement as well. Okay, when you initialize the looping variable, you have to update it. Okay, so as an example, I plus plus. I said I equal to 1, and I'm saying I plus plus. So how many times this loop has to get executed, that is determined by the condition, right? So now, for example, I say I less than or equal to 10. So I equal to 1, and the loop has to execute as long as my I value is less than 10, and every time my I value is getting incremented. Okay, so whatever the loop you take, so these three things are actually common. There is an initialization statement, there is an expression, and there is an update statement. If you see the syntax of the while loop, now where are these properties here? So in the while loop, so this is the syntax of the while loop. Okay, so if you see here, you have the initialization statement. Okay, so this will be something like this, some int I equal to 1. Okay, this is the initialization. And then while expression. So now some condition is required. And this is the loop body. So whatever is there within the braces, right? This is the loop body. This loop body can be of a number of statements. Okay, so this expression determines whether the loop body has to get executed or not. As an example, now the expression I am actually changing like this: I less than or equal to 10. I is 1, I less than or equal to 10. So I is 1 and 1 less than or equal to 10. That is true. 1 less than 10, right? So now when this loop is actually, this expression is true, then we will enter into the loop body. Okay. In while, in do while, and for, the expression always evaluates to Boolean. That means it will have two parts. If it is a true, loop body is going to get executed. If it is a false, loop body will not going to get executed. That means it will be come out of this particular loop body if the expression is false. Okay, so now this loop body we are executing as long as the I value is less than or equal to 10. Now I is 1, right? Now we have to update, we need to have some update statement where we will update our I value. So here I am saying I equal to I plus 1, that is nothing but I plus plus. So every time I value is going to get increased. Okay, or every time I value is going to get incremented by 1. So how long this while loop will execute now? 10 times, because I equal to 1, I less than 10. So 10 times the loop body is going to get executed. When I value become 11, so 11 less than or equal to 10 false, so it will come out actually. Okay, so this is the syntax and the corresponding statement. So here this is the initialization statement, this is the test condition, and this is the update statement or increment or decrement statement. Okay, so this is the syntax of while, and a few details I can actually tell about the while. So in the while loop, if you observe the condition, we are actually checking at the beginning, right? So whenever you are entering into the while loop, we are checking the condition. Since the condition is checked at the beginning, so this is called entry controlled loop. It's called entry controlled loop. Okay, at the entry itself, we are checking. The condition is true, the loop body is going to get executed. The condition is false, it's not going to get executed. Fine, that's why it is entry controlled loop. So if the condition is false, the loop executes 0 times. Okay, if it's false, the expression is false, the loop executes 0 times. That means the loop will never get executed. Okay, so these are the details of the while loop. Let's come to a do while. Actually, the do while syntax is little different when compared to while. So in the while, we are checking the condition at the beginning, but here if you see, the block comes first. That means the loop body comes first. So this is the loop body. You can have a number of statements, and of course we will have an update statement as well. And at the end, we are actually having this expression of the test condition, right? And of it's actually ending with the semicolon here. So here there is no semicolon, but here we are ending it with semicolon. So here the condition is checked at the end, right? So that's why it is called exit control loop. Exit control loop. So now what is going to happen here? Of course, there is an initialization statement. And for example, I want to print 1 to 10. So I have my int I equal to 1. Then do, and here is my loop body. And update statement here I say I plus plus. Okay, and while expression, so here is my condition. So while I less than or equal to 10. So if you observe here, without checking the condition, we are entering the loop. The condition is checked only at the end actually. That's why it is exit control loop. Okay, even if it's false, even the test condition is false, right? The loop executes for 1 time, right? Because you are coming to the loop body, then you are checking, right? So the loop body is getting executed at least 1 time, even if the condition is false, right? So that's the difference actually between while and do while. While is entry controlled, do while is exit control. In exit control, your loop body will get executed for at least 1 time. Okay, so because it has this property, so it is actually will be used to write menu driven programs. It is used to write menu driven programs. So what do you mean by a menu driven program? Firstly, you will be provided with a menu. Later, you have to choose which one you want actually. So that is possible with only do while. So firstly, we will be provided with a loop body. So loop body will get executed, just like a menu is provided to you. Later, you can decide actually whether you want to be there or not. The condition is true, it will be there in the loop, otherwise you will come out it. So these kind of programs are actually menu driven programs. Initially, for example, we will actually provide you a menu: 1 for prime number, 2 for perfect number, 3 for Armstrong number, 4 for some Fibonacci series. Like that, I will give certain menu, and that menu will be displayed. Okay, later if I select 1 or 2 or 3 or 4, I will be in the loop. If I select something else, I will select Q for exit, I will get exited, right? So this is an example of a menu driven thing. Okay, so this is the theory about the while and do while. So let's actually see a few programs. So firstly, I would like to print 10 numbers actually. Print first 10 numbers. How do we print first 10 numbers using the while loop? And then we do while also we can see. Okay, so in order to print first 10 numbers, I don't require any data, right? So I can start from the 1 and I can go up to 10 and I can print it. So I have my initialization statement that int I equal to 1. Okay, this is my initialization statement. Okay, so then straight away I need to write my while loop. While, and you require a test condition, and you want to print how many numbers? 10 numbers. So as long as I less than or equal to 10, you print it. And in order to print, we are saying system.out.println I value. So I is 1, so 1 will get printed. So here is my test condition, that is the second property. Test condition or expression I can say. So this is my first property and this is my second property, and of course I need to have my update statement also in the loop, right? So if I'm not writing any update statement, what happens? Every time your I value is 1 only, 1 always less than 10, so it will become like infinite loop. So if I update it, so I am saying I plus plus, right? So this is my third property, that is update statement. Okay, so now what happens? Every time I value is getting printed, so first 1 will get printed, then actually what happens? I plus plus, and I plus plus means that will be 2 less than 10, again it is true, so 2 will get printed until so on 9 and 10 also will get printed. After printing the 10, I plus plus, that is 11 less than or equal to 10 is false, so you will come out actually. So by the time you have got our output. Okay, so this is simple actually. Working with the while loop is simple, just you need to understand uh, how you have to specify the while loop. So initialization is required and test condition is required and update statement is required. If update statement is not there, then it will become like infinite loop. Okay, so this is my test. So let me compile this Java C test.java. Sorry. Yeah, I have to compile it, right? Let me compile initially Java C test.java. Yeah, now let me actually Java test. Yeah, so it is printing 1 to 10. It is printing 1 to 10. So if you want not 1 to 10, but any other value, actually, you can also do that. Okay, so you want to print 1 to 100, 1 to 50, or you want to print them in reverse, that you can actually do. Okay, so this is actually while. So same thing I can actually do with do while also. So after this, I will start with my do while. So what I do here, I just print some stars, and I would like to print, yeah, so same first to 10 numbers, first to 10 we using do while. So how do I do that? Okay, I require some initialization statement, so this time I am actually taking some x value equal to 1. Yeah, so now I require do, because this is the syntax do, then followed by, so you want to print that x value, so this x value 1 is going to get printed initially, so this is my initialization statement, and do you're printing it, and of course we require an update statement that, let's say, that is I plus plus. Okay, and you should end with the while actually, and the test condition is checked over here. So while x less than or equal to, while x less than to 10, right? Of course this is not I plus plus, this is x plus plus. So here my initialization variable is x, I'm printing x and x plus plus, updating it actually, and at the last I am actually printing the semicolon as well, I'm writing the semicolon as well, right? Yeah, so here initialization statement, this is my update statement, this is my property 1, and this is my property 2. So here it comes the update statement, and at the last you will have your test condition. or the expression, and this is the output actually that is going to get printed. So what happens here? Initially 1 will get printed, so without checking any condition. Then x plus plus, and that is 2. 2 less than 10, true. So again 2 will get printed, goes to the loop. And then x plus plus, that is 3. 3 less than 10, again true. So until so on till 10 actually. So x is 10, 10 will get printed. X plus plus, it is 11. So x less than 11 less than 10, false. So it will come out actually. By the time I will have the output. Okay. The same thing we are actually doing in do while actually. What is the difference? It is getting printed. This value is getting printed before actually evaluating the condition. If you want to check, let's actually compile this and see that both will work perfectly. Yeah, you can actually see 1 to 10, and here actually 1 to 10 is also getting printed. Okay, so since I am printing 1 to 10 here, what I do is I will actually print from 10 to 1. So how do I print 10 to 1 actually? So my loop variable should be 10. Now I want next value to be printed is 9 actually. So what I do? So first I will print this particular 10 value over here. Okay, so the 10 is going to get printed. Then I want 9 to be printed. So what I need to do, instead of saying x plus plus, I say x minus minus. We understand actually these increment decrement operators, right? X minus minus means minus 1 of that x. Then here, so here what I have to say, so I want to print till 1, right? As long as x greater than or equal to 1. X greater than or equal to 1, you can do that. So first 10 we are printing, then minus minus, so 9. So 9 greater than 1, true, right? Then 8 greater than 1. Then 1 greater than or equal to 1 is also true, 1 will get printed, right? Yeah, but later 1 minus minus, that is 0. 0 greater than or equal to 1, then fails actually. Okay, so now my while loop prints print first numbers using while, and 10 to 1 using do while. Okay, so this is the program actually. Now let's see, compile. Yeah, and let's run actually. Now you can see 1 to 10 and then 10 to 1 actually. So this is how the loops will work actually. And there are a number of ways we actually use our loops to do actual problem solving. Okay, so I would like to write one more program here. Yeah, so let me take a program to print prime number, to find whether a given number is prime or not. Okay, a program to find whether a given number is prime or not. How do you do? Whether a given number is prime or not. So how you are going to do? Let's see actually. Okay, so first of all, you require a number. You want to generate a number. You can generate using a random number, and we can take that number and we can actually see whether that is a prime number or not. So I'm going to use while loop for that actually. So what I'm doing is a simple logic I will write. I will actually take a number. So I will generate the number. So that's better actually. So I generate some number into number equal to some random number. So I would like to generate that number from, yeah, so which number we will generate? So let's start actually from 2. Okay, 2, 200 actually. 2 plus I am starting from 2 actually, because 2 is the first prime number, right? Yeah, so 1 is not a prime number because it has only 1 is not considered as a prime, and 2 is considered as a prime number actually. So I am starting from the 2, and here I would like to convert that random number which is getting generated to integer. So for that, this is what we have learned already. And of course, we have the math.random that is to generate the random number. Math.random into now 100. Okay, so this is the number that I would like to generate. Actually, now what happens? So math.random into 100. So actually it will generate 0 to 99, right? Now what I am doing actually plus 1 plus sorry plus 2 plus 2 means it will become 2, and plus 2 for 99 is actually 101. So 2 to 101. So you don't want 101, you want only 100. Now what you do, you just multiply this with 99. Just multiply with 99. So 99 numbers, so that is 0 to 98. So I'm adding actually 2, right? So first number will be 2 and the last number will be 100 actually. So this is how we can generate a random number from 2 to 100. And let's print this. Let's print this before actually we find whether it's prime or not. Yeah. So what is the logic for prime number? What is the logic for prime number? So what is a prime number? So prime number is a number which has just two factors, right? This is the very basic logic, just two factors. What are those two factors? Okay, one is the factor and itself is also the factor. One and itself is the factor actually. Okay, so let me actually make use of this logic to do that. Yeah, so what I do, so I need to find the factors of this particular number. So how do I find the factors of this particular number? Okay, so now I have to, I should start dividing that number from 1 till that number actually. So that is the reason I require a variable that is called I, which is initially equal to 1, which is initially equal to 1. And this I value is actually dividing that number. Initially it is 1 and then 2 until so on up to that number actually. So my while loop is going to be like this: while I less than or equal to this n, because I have to divide this number. N is nothing but my number. I have to divide this number with 1, 2, 3 until so on that number, right? So prime number is a number which will have two factors, 1 and itself, right? Yeah. So now what else also I do is I will actually take one count variable just to count the factors. So initially the count value equal to 0, and my logic like this: while I less than or equal to this number, and here what I am going to do, I am going to increment this I plus plus. First it is 1, then 2 until so on. But here in the while loop, I would like to write my if also, because I have to check whether this I value divides that particular number and gets remainder. Then only it becomes a factor. So that's why I'm saying if number modulus of I equal to 0. Okay, if number modulus of I equal to 0, that means what? Whenever this condition is matched, then it's a factor. Okay, then it's factor, right? So when it's true, then it's a factor. Okay, so whenever it is true, now what I do, I just make count of it. So I will count plus plus. So what I'm doing, count equal to 0 initially, right? So I'm actually keeping the count. Whenever it is I value is a factor, my count value is going to get increased actually, right? Updated. If it is not a factor, it is skipped actually and I plus plus. So it will go to the next value. Okay. And then next also try to divide and find whether it is 0. If it is factor, then it counts actually. Okay. And if it's not a factor, then I plus plus, and it goes over here, next value until so on. This I value is bigger than this number. These things are actually being executed. Once you are done, so when our I value is greater than this number, we will come out. Okay. By the time when we come out, what has happened? We have that count variable got updated, right? Every time we are saying count plus plus whenever it is divisible by I value. If it is a prime number, at least it is divisible by 1 and itself. If it is not a prime number, the count value is so much, right? So now what I do, I will again write one if statement. If this count is equal to only 2, if the count equal to only 2, then we can say whatever the variable that we took, right? That number is a prime number. That number is a prime number. Okay. Else, if the count is not equal to 2, then what actually happens? The same thing, I just copy this and I say is not prime number. And I say he is not a prime number. That's it. So a little bigger program actually as part of the basic programming constructs. Okay, so the thing here is how I am using while actually. And in while I am using if statement because I have to check the condition whether it is divisible or not. And later once I came out of the while, again I am actually checking using if I'm taking a decision. If the count is equal to 2, that is only 2, then it's a prime number, otherwise it's not a prime number. Okay, let's see whether this will work or not, and hopefully it should work. Java C main.java. Let's check for compilation errors. Yeah, no compilation errors, everything was fine. And Java, then I say main, and random number is going to get generated. Yeah, now 13 got generated, and 13 is a prime number, right? So now see the program, how it is going to get executed. So 13 got generated. Now what happens? I less than number, I equal to how much? 1. 1 less than 13. And the 13 modulus of 1 equal to 0. So 1 divides any number. So count will be 1. Then I plus plus 2. 13 modulus of 2 not equal to 0. And 3, 4, 5 till 13, no one divides actually. Now 13 mod 13 equal to again 0. Then your count value is only 2. Right? So if the count equal to 2, it's a prime number, otherwise not prime. But let's check for other trial. 84 is not a prime number. Then 89 again is a prime number. And then 100 is not a prime number. 76 is not a prime number. 85 is not a prime number. 90 is not a prime number. And 17 is a prime number actually. Right? It's working for all the cases actually. Okay, so this is one of the examples of while loop. Of course, the same thing you can write in for loop also, but it is actually easy to write with the while loop. Okay, so hope you have understood this while and do while loops, which are in fact same. Most of the time you will not be using do while, other than unless and otherwise it is actually a menu driven program. Okay, and the sample examples, the basic examples of actually the while is just like this, finding a number is prime or not. And of course you can also find factors of some number, and you can also by using the same logic you can find whether a number is perfect or not, like that. So hope you have understood this while and do while loops, which are actually looping or iterative statements in Java. We will actually see the for and the for each style in the coming session. Thank you.